Hi all, this is Nandini from Hindustan College of Engineering and Technology, working as an Assistant Professor Physics. Today's session with a quote, "Imagination is more important than knowledge. In middle of difficulty lies opportunities." In this session, we are going to start the Unit 5 Ultrasonics. Today topics are piezoelectric effect, inverse piezoelectric effect, piezoelectric oscillator. So first of all, what is mean by piezoelectric effect? When a certain crystal like quartz are subjected to mechanical stress on opposite phase, electric charges appears on the opposite face of the crystal. This effect is called piezoelectric effect. So in this diagram, I have shown you the quartz crystal where I am giving the mechanical pressure and the electric charges are appearing in the opposite faces of the crystal. Then inverse piezoelectric effect. When alternating electric field is applied on the opposite face of the quartz crystal, alternative mechanical deformation, that is expansion and contraction, is produced across the other pair of opposite faces of the crystal. This effect is called inverse piezoelectric effect. This is also called electrostriction. Here I have given you the alternative electric field on the opposite faces of the crystal, and hence the ultrasonic waves are produced by the expansion or the contraction of the quartz crystal I have used in here. Then here I have shown you some of the examples and their axis along the x-axis and the y-axis, like quartz crystal, barium titanate and tourmaline. Here I have shown you how the view of the quartz crystal in x-axis and view of the quartz crystal in y-axis. Then piezoelectric oscillator. So here I have shown you the construction of the piezoelectric oscillator. Here I have used the capacitor, then NPN transistor, L1, L2 and L3 inductor. When a battery is switched on, the current is produced in the transistor. The produced current is passed through the coil L1 and L2 of the primary circuit. This current is transferred to the coil L3 in the secondary circuit due to the transformer action and is fed to the plate A and B. Due to this principle of inverse piezoelectric effect of the crystal starts to vibrate along the mechanical axis of the crystal. The frequency of the oscillatory circuit is adjusted by the capacitor C1, and when this frequency is equal to the frequency of the vibrating crystal, resonance occurs. At resonance condition, the crystal vibrates vigorously and ultrasonic waves are produced along both the ends of the crystal. So conditions to produce this ultrasound: the natural frequency of the vibrating crystal n equal to p by 2l root of e by rho hertz. Frequency of the oscillator f is equal to 1 by 2 pi into root of L1 C1 hertz. Here Y is the Young's modulus of the material. Here I have mentioned in the equation as capital E, and rho is the density of the material, L is the length of the rod, and P is the fundamental, that is the external mechanical force I have given. Okay, next is the quartz can produce the ultrasonic frequency of 540 kilohertz and tourmaline can produce the ultrasonic waves of around 1.5 millihertz. What are the advantages of this piezoelectric effect? It can produce the ultrasonic frequency as high as 500 million hertz, and the output power is high and frequency not affected by temperature and external humidity. It is more efficient. It can produce longitudinal as well as transverse ultrasonic waves by properly cutting and shaping the crystal with respect to the optic axis. Using synthetic materials like ceramics, then barium titanate oxide, we can generate a wide range of frequency at lower cost. The main disadvantage is the cutting and shaping of the crystal is very complex. Here we can end the session with the thank you note, that is, victory goes to the player who makes the next to last mistake. Thank you all.